Okay, good morning, all of you. So, in the previous class, we have started the concept of methods. Okay, so what is a method and what are the different types of methods we have seen. Okay, so method is basically so it is a subprogram. Okay, so a method is as we discussed, a method is a subprogram so which performs a specific action or a specific function. So this is what we have defined. What is a method? Okay, a method is a subprogram so which performs a specific action. So that is for simplicity or for modularity. So what we have to do is we need to divide the larger programs into smaller ones. Each individual part is known as the method or also known as a function. Okay, it is also known as a function or it is a method. So a method performs a specific task or a specific function, whatever you have mentioned, right? So that is called a method. And also we have seen different types of methods. So types of methods. So so different categories you have seen. So method with arguments and with a return type, with argument and with the return type, or with argument or without return type. Okay? So these are the two categories, one and two. And the second category is without arguments and with or without return type. Okay. So these are the different categories of methods. Okay. So that is with argument, so second category without arguments and with or without return type. Okay. So these are the four categories of methods, right? So that is a method may takes arguments or it may not take arguments. Okay. Suppose if there are arguments are there, the function may return value or it may not return value. That is two possibilities are there. Okay. And next, without arguments, there are no arguments and without return type or sometimes it may not return any value. That is what is this return type? Return type means type of value to be returned by a method. Okay. Suppose if a method returns integer, its return type is integer. If a method returns a float, its return type is float. If a method returns boolean value, its return type is boolean. Okay, so like that you can return a value depends upon the specify a data type depends upon the value returned by the method. Okay, these are the different types of methods. This is what we have seen in the previous class. So and also so all of you please kindly mute yourself. So please kindly mute yourself, all of you. So these are the different types of methods, and also have seen what is method overloading. So in the previous class, I have also seen that what is method overloading, right? So what is method? Method overloading also we have covered. Okay. So what is method overloading? So overloading refers to using the same method name. Okay, you can use the same method name with method name is same, but with different number or types of arguments. Okay, different number of arguments or types of arguments are with different return type, different return types. So this is known as method overloading. Okay, so a method takes same name. That means we can use the same name, but the number of arguments may be different, or the types of arguments may be different, and sometimes the return type will be the different. Okay, so that is known as the method overloading. So this is one of the concept which comes under object oriented programming. So that is polymorphism. Okay, so we know what is polymorphism. Polymorphism means the ability to take more than one form is known as polymorphism. Suppose the method, one method will be there. So depending upon the context, depending upon the type of arguments specified or number of arguments specified, now the operations may be varied. Operations may be varied. It performs different operations at different instances of times. So that is known as the method overloading, that is polymorphic behavior. So one of the form of polymorphism is also known as the compile time polymorphism. One of the best example for this compile time polymorphism is method overloading. Okay, so method overloading is one of the polymorphism, compile time polymorphism technique. Okay, this is what we have covered in the previous class, earlier classes. Okay, in the previous class we have covered this part. Okay, so now in today's class we'll see. So what are different types of parameter passing methods used in the methods? Okay, so another important point here we have to discuss is parameter passing methods, parameter passing methods. So parameter passing methods. So what are parameters? So in order to invoke the method, you need to pass some parameters to the method, because in the method header, we need to specify some parameters. Okay. So for example, so there is a method called void swap int x comma int y. So there are two parameters are there, okay, in the method definition. So here you can write the logic here. So here we have two different variables, x comma y. So these are called formal parameters. These are known as the formal parameters or formal arguments. Okay. So now if you want to execute this, what you have to do is you need to write inside this main. So pass, let us take some variable integer a equal to 10 and b equal to 20. So then write swap of a comma b. Swap of a comma b. So where a and b are called actual parameters. A and B are called actual parameters. Okay. So now in order to execute this, what we have to do is, so you need to pass the values of actual parameters A and B to formal parameters. Okay. Here A is the actual parameter, B X is the formal parameter. And here B is actual parameter, Y is formal parameter. That is, value of A needs to be copied into X and value of B needs to be copied into Y. Okay, that means you need to pass some parameters A and B to X and Y, the values of A and B to X and Y. Now, such a mechanism is known as the parameter passing method. Okay, so what are different types of parameter passing methods? How many ways we can pass parameters to these particular methods? Okay, so that is known as parameter passing methods. Okay, so basically, so there are two types of parameter passing methods. So in Java, there are two types of parameter passing methods. So one is known as call by value, and second one is call by reference. Call by reference. So even in C and C++ also, so we have these two approaches. One is the call by value approach, and next one is the call by reference approach. So now in call by value approach, what we have to do is in call by value approach, so we can call a method so by passing values. Okay, by passing values of actual parameters, what we can do is we can call a method. Okay, that is known as the call by value. That is by passing the values of actual parameters to formal parameters. Okay, by passing values of actual parameters to formal parameters, we can invoke the method called swap. Okay, so similarly, in call by reference, in general, in call by reference, what you have to do is call a method by passing reference, by passing reference. So in Java, in C++, in C and C++, we can achieve this by passing address. We can achieve this by passing the reference means address actually, by passing the address. Now, in order to pass the address, we need the concept of pointers. We need the concept of pointers in C and C++. Because in C and C++, we have the concept of pointers so that we can implement this call by reference mechanism by passing address directly. Okay, how? By using reference variable or a pointer variable in the case of C and C++. But in Java, there is no concept of pointers. So that how can you implement this call by reference? So only the option is by passing the object. So object is a reference variable. Object acts as a reference variable so that we can pass object as argument to a method. Okay, so that's what we'll see later. Now first consider call by value mechanism, how it works. Okay, call by value mechanism. So now the first approach is, so the first thing is call by value. Okay, what is the first approach? The first approach is the call by value mechanism. This is the first mechanism. Now in this approach, what you have to do is in call by value mechanism, what we have to do is, so we need to invoke a method, by passing values of actual parameters to formal parameters by passing the values of actual parameters to formal parameters. So we can implement this call by value mechanism. Okay, we can implement the call by value mechanism. So for example, let us take same example, the swap example. There is a mechanism called swap int x and int y. Two are there here. So now there is an implementation for this. The implementation for this. Okay. So later on in the main program, what you have to do is swap a comma b. Suppose swap a comma b. So where a equal to 10 and b equal to 20. So now what happened? The value of A and value of B copied into X and Y. There, inside this method, X and Y acts as a local variables. X and Y acts as local variables. Okay. So this will write outside this. Okay. So now when you pass the values of actual parameters to formal parameters, what happened is then the variables x comma y acts as a local variable. Okay, local variables. Now what is the problem if x and y acts as a local variables? So now whatever the modifications, oh, okay, whatever the modifications made inside the method, whatever the modifications made inside the method, which are which does not reflect in main. This is the main disadvantage. Okay, this is the disadvantage with this call by value mechanism. Now once the values of x and y swapped inside this, okay, so for example if you write temp equal to x and x equal to y and y equal to temp. Okay, now the modification, that is swapping, is successfully over inside this method. Okay, swapping is successfully completed inside the method. But when you comes out from this particular method, the values of a and b remains the same. A equal to 10 and b equal to 20. Okay, so that the modifications made inside the swap method are not reflected outside the swap, that is inside the main method, so that the values remains same. So this is the disadvantage with the call by value mechanism. Okay, we'll see one example also. Okay, so let us take one example which illustrates the call by value mechanism. Notepad CBV call by value mechanism dot Java. So for example, let us take class test. Okay, let us take one example, void math integer I and integer j. I and j, let us take, for example, I equal to I star 10 and j equal to j star 20. Okay, j equal to j star 20. I equal to I star 10, j equal to j star 20. Okay, so this is a simple example. Next, write main method class call by value. So inside this public static void main string args, okay, string args. So here let us create an object for test class test t equal to new test, and let us take integer a equal to 10, b equal to 20. System dot out dot println. Now first print the value of this a and b. First print the values of a and b. Then call the method t dot method of a comma b. Okay. And again print the value of a and b. Again print the value of a and b. Okay. So now let us compile this code. So Java C CPV call by value dot Java and Java CBV call by value. Now before call the value of A and B is 10 and 20, and after call this method again the value of A and B becomes 10 and 20, even though I modified the values of I and J here. Now when you pass this, when you call the method t dot math, the value of a is copied into I, value of b will be copied into j. Now there I equal to I star 10, j equal to j star 20. So will be done. Okay, but these modifications are not reflected in the main. Suppose if you want to see inside this method system dot out dot println, suppose I equal to I equal to something, okay, and j values, print j values, okay. So this is inside math. This is inside math, okay. I and j inside math, I and j values. So again compile this. Okay. So here you can write Control C dot out dot println. This is inside math. Okay. Inside the math. So I and j. So and then Java call by value. Okay. So this is I and j, A and B values 10 and 20 initially. Now inside math, what we did, I equal to I star 10, that is 10 star 10, 100. J equal to J star 20, 20 star 20, 400. Now inside math, values of A and B becomes 100 and 400. But when you come back to this main method, the values of this A and B remains 10 and 20. Values of A and B remains 10 and 20. So this is the disadvantage with this call by value mechanism. Okay, whatever the modifications you made inside the method does not reflect, this is does not reflect in main. So this is called the call by value mechanism. This is the disadvantage of call by value. Now we have to eliminate this. How to avoid this? By using the next method, call by reference mechanism. Next approach is the call by reference. Call by reference. The name itself tells us the reference. What is the reference? So by passing reference. So what is the reference in Java? So in Java terminology, reference means object. Reference is nothing but object because there is no way to pass the address. In general, in C and C++, reference means address. Okay, so we can pass a reference variable. Reference variable means pointer variable. Using pointers, we can implement the reference concept in C and C++. But in Java, there is no concept of C and C++. There is no concept of pointers. So that only the way is you have to pass the reference variable or object. Pass object to a method by passing reference or object to a method. So we can implement call by reference. Okay, call by reference mechanism. So this is the only way of implementing call by reference mechanism in Java. Now what happened when you pass the call by when you pass the reference or object to a method? So when we pass reference to a method, when you pass a reference to a method, okay, so when we pass a reference to a method, what happened is the parameter that receives it will refer to the same object as that reference to by the arguments. Okay. So when we pass a reference to a method, then what happened is the parameter that receives it will refer to receives it will refer to the same object same object as that referred as that referred, not reference, REFFE or RED, that referred to by the arguments. So that is both actual parameter and the formal parameter. Okay, actual parameter and formal parameter points the same object. That is, same object is used to refer both actual parameters and the formal parameters. Okay, so that both are acts as the same thing, same variables. Okay, so that what happened is, so whatever the changes made to the object inside the method also affect the object used as an argument. Okay, so changes, whatever the changes made inside the method do also affect the object used as an argument. Now, for example, we have two different methods here. Okay, we have two different methods. Suppose here swap, there is a class test t. Okay, so now inside this, what you have to do is t dot. Suppose what you can do is temp equal to t dot a. Okay, then t dot b equal to temp equal to t dot a, and t dot a is equal to t dot b, and t dot b is equal to temp. T dot b is equal to temp. Okay, so like that you can use this. Okay, so here what is this test? Now here test is the test acts as a formal parameter. What is this formal parameter? If test is a class, now it creates a reference variable. This is a reference object. T is an object. It is also known as the reference variable. So the temp equal to t dot a, and t dot a equal to t dot b. T dot b is equal to temp. Now inside this class, suppose test t is equal to, what you can do is you can create an object like this. Test t is equal to new test. Test t is equal to new test. Then write int x equal to 10 and y is equal to 20. Okay, y is equal to 20. Then call t dot swap of t. T dot swap of t. What is this t? T dot swap of t means this t represents this particular class. Okay, t represents this particular class. Now this t consists of, for example, the test class has, uh, let us remove this part so more clearly we'll see. Okay, so now let us create an object test t is equal to new test of 10 comma 20 here. Suppose 10 comma 20. Okay, so or before this you can create one variable like this. Okay, int a equal to 10 and b equal to 20, then pass a comma b, then pass a comma b, then call the method t dot swap of t. Now this t represents this both a and b are the values. Okay, so now the same t, this receives this t acts as the actual parameter here. This acts as a formal parameter. Now copy the reference of this t to this tip of this particular t. Now both points same memory. Both points same memory. This is 10 and 20. This t and this t. Both points same locations. So that whatever the modifications you made inside this swap method are also reflected in the main. Also reflected in the main. Okay. So this is called the call by reference mechanism. This is known as the call by reference mechanism. Okay, now let us see one example. Same example earlier what we have discussed. This one. Okay, so now here what you have to do is let us add one constructor here. Add one constructor. Here write int a comma int b. Okay, so inside this, sorry, here you can take int x comma y. Okay, now x equal to a and y equal to b. This is for initialization of the instance variables x comma y. Okay, so then here what you have to do is inside this math, now this will not take variables. Now it take one reference variable. Okay, so here what you have to do is test t. Now you can directly use T dot X is equal to T dot X star 10. Then T dot Y is equal to T dot Y star 3. Okay. T dot Y star 3. So like that you can use. Okay. So then here what you have to do is, so test 10 and 20. Test 10 and 20. Then print here. So T dot X and T dot Y before calling this meth. Now don't pass A and B. Now pass object as argument. This object as argument. Now this is T dot X. And now this is T dot Y. T dot X and T dot Y. Yep. T dot X and T dot Y. Okay. So now when you pass this object as actual parameter to this math method, now the actual reference variable is copied into T. Now both points same, both are acts as aliases here. Okay, this T is alias to this T, so that both are belongs to the references of the same. Okay, this is a object actually. Then this is passed as argument to this particular method. So both points the same. Okay, both variables, both objects point the same memory locations x and y, where x and y are stored. So that whatever the modifications you made here, so both are affected in the main also. Okay, so both points the same. Okay, so let us compile this. Java C, call by value in Java C. Now see here, earlier it is 10. Okay, earlier it is 10 call by value and it is call by reference. Okay, y equal to y star 3. What is y 3 into 60? Okay, okay, this is x equal to x star 10. Okay, x is 10 and y is 20. Okay, so both are, this is y now, which is y, x and both are printing x and y. So compile C and compile. Now before call x is 10, y is 20. After call x equal to x star 10, 10 star 10, 100, and y equal to y star 3, 20 star 3, that is 60. Okay, 20 star 3, that is 60. Okay, so this is known as the call by reference mechanism. Okay, so if you want to make a note of this program, you can note down. Okay, please make a note of this program. So this is regarding the call by value and call by reference mechanisms. Okay, so and next let us see another important concept related to the methods, recursion. Okay, next one is the recursion. So let us discuss about recursion, right? So what is recursion? We know what is the meaning of recursion. Okay. So in general, recursion means, what is recursion? Recursion is the process basically. Recursion is the process of sorry. Recursion is the process of defining something in terms of itself. Okay, that is the general meaning recursion. Okay, recursion is the process of defining something in terms of itself. Okay, so or you can also define recursion is the attribute. Recursion is the attribute that allows a method to call itself. This is another way of defining recursion in terms of program. Okay, so recursion is the attribute that allows a method to call itself. So that means if a method calls itself, if a method calls itself is said to be recursion. Okay, if a method is said to be if a method calls itself is said to be recursion. So what is a recursive method or what is a recursive function? Suppose if a function or if a method calls itself, then it is known as recursion. Then it is known as recursion. Okay. So what is a recursive method? If a method calls itself is known as recursive method. Okay. So this is the general concept which exists in both C and C++ languages. So it is also there in Java language. Okay, it is also available in the Java language. So what is recursion? Recursion is basically if a function calls itself or if a method calls itself is known as a recursion. Now one of the classical example for illustrating recursion is the finding factorial of a number. So finding factorial of a number is the classical example for recursion. Basically, we aware. Suppose if n equal to 4, then you can find out the recursion factorial of this n. In general, fact of n is, so this is 1 star 2 star 3 star 4, that is equal to 24 in general. Okay, that is factorial of a number means multiplying from 1 to n. The result of multiplication from 1 to n. 1 into 2, 2, 2 into 3, 6, 6 into 4, 24. That is okay. Now this we can represent in terms of recursion. Okay, how can you implement this in terms of recursion? For example, write a method int fact of int n. I want to find out the factorial of n. Okay, for example, if this n is equal to 1, then what you have to do is if n equal to 1, simply return 1. Simply return 1. So return otherwise return this n star, again fact of n minus 1. That's it. Fact of n minus 1. So this is called the recursive function. This is called the recursive function to find the factorial of a number. Okay. Suppose if n equal to 4, let us take again n equal to 4 here. And then this n is equal to 1. This is not satisfied. So then control goes to this one. Okay, so that fact of n minus, that is fact of n. What is n? This is 4 minus fact of n minus 1. What is this fact of n minus 1? This is fact of 3. Again, this calls itself. It is not equal to 1, so that again it is going to evaluate like this. This is the fact of 2 and minus 1 means 2. What is this fact of 2? It is not equal to 1, so that it is again 2 star fact of n minus 1 means 1. So what is this 1? Fact of 1 means if n equal to 1, return 1. So this is 1, 1 star 2, this is 2, 2 star 3, this is 6, 6 star 4, this returns 24. This is winding up the results. Okay, this is how the recursive process will continue. Okay, this is the way of implementing recursion process. Okay, so this is the thing which was implemented using recursion. Okay, so for example, if n equal to 0 or n equal to 1, that is return 1, otherwise return n star fact of n minus 1, n star factorial of n minus 1. This is factorial of 3 means again 3 star, this is fact of 2, this is 2 star, this is fact of 1. Okay, now if it is 1, returns 1, 1 star 2, 2, 2 star 3, this is 6. Okay, so this is the factorial example. So now let us see one complete example. Okay, so let us take one example. So factorial demo dot java using recursion. So now let us write one class fact, and here int fact fact int n. So here you can write if n equal to 1, return 1, else return n star fact of n minus 1, n star fact of n minus 1. Now write the main class fact demo. So here public static void main string args. Inside this fact f equal to new fact f equal to new fact. Now if you want to find out factorial, system dot out dot print ln. Now factorial factorial of factorial is here f dot fact of 5, suppose. Okay, factorial is f dot fact system dot out dot println. Okay, factorial is f dot fact of 5. Now 5 is copied into n. n is not equal to 1, return factorial of n star fact of n minus 1. Okay, so this is java c fact demo dot java, then java fact demo. Okay, factorial of 5 is 120. Okay, so suppose if you want to find out factorial of all numbers, suppose for integer I equal to 2, sorry, integer I equal to 2 and I less than or equal to I less than or equal to 9 and I plus plus, and I want to find out factorial of I. Factorial of factorial of write this I is okay. So factorial is, you can write this. F dot fact of I. Okay. So 2 factorial, that is 2 is 2, 3 is 6, 4 is 24, 5 is 120, 6 is 720, 7 5040, 8 40320, and 9 362 980. So like that you can invoke multiple times. Okay. So this is one classical example for finding out factorial of a number using recursion. Okay, this is what exactly known as recursion, right? So what is recursion? Recursion is the process of defining something in terms of itself. This is called a recursion. Okay. So that is if a function or a method calls itself is known as the recursion. Okay. So this is about the recursion. So in the next class, and so this is about the methods. What is a method and how to define a method, and what are different types of methods, and what are different types of parameter passing methods. What are parameter passing methods? Call by value mechanism and call by reference mechanism, and how it works. What happened in call by value mechanism and what happened in call by reference mechanism. That is about parameter passing methods. And another thing is the recursion. What is recursion and how it works. One of the best example for recursion is the finding factorial of a number. So another example is also there, that also we'll see how to find Fibonacci series. Notepad Fibonacci demo.java. Okay. So using recursion class, for example, this is FIB. So class FIB. Now let us write one function called Fibonacci integer n. So here what you have to do is write one if condition. If n equal to 0 or n equal to 1, either n equal to 0 or n equal to 1, return n. That's it. Else return a fib of n minus 1 plus fib of n minus 2. That's it. So what is a Fibonacci series? You know. Okay. What is Fibonacci series? Fibonacci series is nothing but a number. Okay. You can get a number by adding previous two numbers. So public static void main string args. Okay. Public static void main string args. Right. So let us create an object fib f equal to new fib f equal to new fib of for integer I equal to 0, I less than 10, I plus plus. Okay. System dot out dot println f dot fib of I, f dot fib of I. Okay. Now this is going to generate the Fibonacci series. Fib f equal to new fib of 0. 0 means it returns 1. Fib of again 1. 1 means it returns 1. Okay. So fib of 2. Fib of 2 means fib of 2 minus 1 and 2 minus 2. That is 0 and 1. 2 minus 1 means 1 plus 2 minus 2 means 0. That is 1 plus 0. That is again 1. You will get 1. Okay. So like that, it is going to repeat, okay, for all numbers. That is Java C system SYSTM, sorry, system dot out dot println. Okay. Mm, Java FIB demo. If demo. Now this is 0 and 1, 0 plus 1, 1, 1 plus 1, 2, 2 plus 1, 3, 3 plus 2, 5, 5 plus 3, 8. Okay. So 8 plus 5, 13, 13 plus 8, 24, 21, 1 plus 13, that is 34. So like that, we can get the Fibonacci series. So this is the best example for writing using recursion to generate Fibonacci series. So this is about recursion, right?